Ooh? Ooh? Fuh? That was the exact reaction of radio scientist Dr. Elara Cade when she stumbled across a strange, massive structure in deep space back in 2019. What she saw billions of light years away looked like a ghostly smoke ring drifting across the cosmos. A glowing anomaly of radio waves, one that didn't fit neatly into any category we already knew. It wasn't a supernova remnant. It wasn't the aftermath of galaxies colliding. So what on Earth, or rather, what in the universe was it? As it turns out, this bizarre object wasn't unique. Scientists eventually gave these phenomena a name: odd radio circles, or ORCs. And they've become one of the strangest puzzles modern astronomy has to offer. Since Dr. Cade's discovery, at least 5 confirmed ORCs have been cataloged, with several other candidates under review. Each one stretches up to 1,000,000 light years across 10 times the size of our own Milky Way galaxy. What kind of cosmic engine has the power to carve something so impossibly vast? Could these radio rings be relics of galactic rebirth, or echoes of an event so foreign we can't even imagine it yet? And if they really are out there in such size and number, why have we only just begun to spot them? I'm Daniel Cross, and you're watching Cosmos Unveiled. Today, we'll dive into one of astronomy's newest and most confounding mysteries, as we break down the 4 leading theories that may finally reveal the origin of these strange radio giants. The story of ORCs begins with a leap in technology. Around the early 2000s, radio astronomy experienced a revolution. For decades, the catalog of known radio sources hovered in the low millions. Then came a new generation of telescopes, machines powerful enough to see what no instrument before them could. One of the most important upgrades was Australia's Southern Sky Array Pathfinder, or SSAP, with 36 massive dishes, each 12 meters wide. It was designed with a unique phased array feed that allowed it to scan enormous sections of the sky at once, something earlier telescopes simply couldn't do. Its field of view covers about 30 square degrees, which is the same as looking at 150 full moons in the sky at the same time. This breakthrough gave astronomers an edge. They could now filter out interference from things like satellites, which often clutter older radio surveys, and they could detect even the faintest whispers of diffuse objects floating across the void. Dr. Marcus Rowan, a senior astronomer at SSAP, spearheaded an ambitious project known as the Celestial Evolution Survey, nicknamed CES, inspired by indigenous star traditions. Until that point, all radio telescopes combined had mapped about 2.5 million radio sources. But CES alone was expected to boost that number to a staggering 70 million. Dr. Rowan predicted these surveys would produce plenty of surprises. He was right, and much sooner than anyone imagined. The project mapped areas of the sky that had never been examined in such detail before, producing mountains of data. Scientists even anticipated needing machine learning to make sense of it all. But it wasn't an algorithm that spotted the first ORC instead. It was Dr. Elara Cade herself, armed with nothing more than her eyes and a sharp sense of curiosity. While scrolling through early CES images, she noticed strange shapes that didn't resemble any familiar cosmic structure. On one particular image, she saw a perfect ring of radio emissions floating like a phantom smoke circle across the stars. Stunned, she jotted down the letters WTF next to it. She had never seen anything like it. When she shared her finding with colleagues, including Dr. Rowan and fellow astronomer Elias Trent, they began combing through the survey images in search of more. Within days, another one appeared. And soon enough, the team gave these strange formations their now famous name, odd radio circles. At first, some wondered if these were mere glitches in the telescope. But with confirmation from independent observatories, the truth became undeniable. ORCs were real. And that begged the question, what are they? This is an image of the very first ORC discovered. At first glance, it looks like nothing more than a fuzzy gray blob. But when enhanced and colorized, the object reveals itself as a glowing blue-green halo, a cosmic smoke ring, a mystery etched across 1,000,000 light-years of empty space. Because these strange cosmic rings can only be detected in radio wavelengths, the colors you see in enhanced ORC images aren't natural. They're added so we can visualize and highlight their structures more clearly. This artificial coloring helps reveal subtle features within the haze that our eyes would otherwise miss. Initial studies placed Orkin -1 at about 1 billion light-years from Earth, with an estimated diameter of 1,000,000 light-years. But later observations suggest it may actually stretch closer to 2,000,000 light-years across, about 20 times the width of the Milky Way. The sheer scale is mind-boggling. So now we know their size and distance. But the real question remains, what exactly are ORCs? At first, some scientists speculated they might be the remnants of colossal supernova explosions. But that idea quickly unraveled. For one, supernova remnants are usually found closer to the galactic plane, whereas all detected ORCs are located much farther away. On top of that, several ORCs appear to have galaxies positioned at their centers, something we don't associate with typical supernova debris. And most importantly, the scale doesn't fit. While supernova remnants usually measure just a few dozen light-years wide, ORCs balloon out to hundreds of thousands or even millions of light-years in diameter. Clearly, they are not the ashes of dying stars. Another idea is that they could be linked to radio galaxy jets, powerful streams of plasma ejected by galaxies with active cores. But at extreme distances, or depending on our angle of view, these jets might blur into strange shapes that mimic circles. To test these possibilities, astronomers use South Africa's Karoo Array telescope, or KAT-64, a network of 64 linked dishes. A team led by Dr. Marcus Rowan studied ORC-1 for 10 hours and combined that data with optical observations from the Dark Sky Survey. The result: an elliptical galaxy appears to sit near the center of ORC-1 at a staggering distance of about 5 billion light-years away. But the surprises didn't stop there. The deep radio image revealed knots and arcs of emission within the ring, and at some of these knots, additional galaxies were found. If the central elliptical galaxy is indeed at the heart of the ORC, it might have played a role in sculpting this enormous radio halo. Then again, its location could be nothing more than a coincidence lying along our line of sight. In 2022, Dr. Rowan and his colleagues laid out 3 main hypotheses that could explain ORC-1's origin. None stood out as definitive, but all were compelling. Hypothesis 1: Black hole merger shockwave. The first theory suggests that ORC-1 is the aftermath of a cataclysm within its central galaxy, such as the merging of 2 supermassive black holes. This violent event would release shockwaves in all directions, energizing electrons in the surrounding medium. The result: a vast, spherical shell of radio emissions, appearing to us as a glowing circle with a brightened edge. Supporting this idea, Several ORCs, including ORC1, do indeed show signs of active galactic nuclei, the kind expected if a supermassive black hole were involved. Hypothesis 2. End on radio jets. The second explanation is that ORC1 is simply a radio-loud active galaxy nucleus, AGN, viewed from a special angle. AGNs can shoot out plasma jets extending hundreds of thousands of light years. If we happen to be looking straight down one of these systems, the twin lobes of radiation could overlap, creating the illusion of a circular ring with a galaxy in the middle. While this theory fits some features, researchers still need detailed 3D simulations to confirm whether the AGNs associated with ORCs could really produce such perfect-looking circles. Hypothesis 3. Starburst termination shock. The third possibility is something even more exotic. A starburst termination shock. Imagine an elliptical galaxy going through a brief, explosive period of star formation, producing millions of new stars in just a few tens of millions of years, a blink of cosmic time. As these stars released powerful stellar winds, those wings could have expanded outward for billions of years, energizing electrons and eventually forming a spherical bubble of radiolight. In detailed models, this explanation proved mathematically possible. However, Dr. Rowan emphasized that the current data doesn't strongly favor this scenario over the others. In the end, no single answer explains everything. What astronomers are increasingly realizing is that not all ORCs are the same. The term odd radio circles is really just a descriptive label, a broad category for any strange, circular radio structure we can't yet classify. While all odd radio circles fall under the same descriptive label, each one seems to carry its own unique origin story. The discovery of ORC-2 and ORC-3, the second and third circles identified, didn't solve the mystery of their formation. Instead, it deepened it. In early survey images, ORC-2 and ORC-3 appear very close together, almost touching. Both are roughly the same size, but their appearances differ drastically. ORC-2 shows up as a bright, well-defined ring on the right side of the frame, while ORC-3, to the left, is faint and disc-like. Without the subtle clustering of light gray speckles forming a circular pattern, ORC-3 might have gone unnoticed entirely. When enhanced in color, the differences become even more striking. Radio emissions highlighted in red overlay the original green pattern. ORC-2 glows as a crisp ring, while its dim neighbor, ORC-3, lingers as a diffuse, hazy shadow. Their proximity strongly suggests a relationship, yet their contrasting appearances raise more questions than answers. Published in 2021, these two sister ORCs remain unsolved enigmas. Before turning to the next case, it's worth mentioning ORC-5, detected in 2021 with data from Australia's Southern Sky Array Pathfinder. This circle, like ORC-1, contains a central elliptical galaxy, but uniquely, it also has a neighboring galaxy at nearly the same distance. The two galaxies appear to be interacting gravitationally. While scientists don't yet have a working origin theory for ORC-5, the discovery adds to the sense that while ORCs share certain features, no two are identical. With only a handful of confirmed cases, it's been impossible to settle on a single explanation. Which brings us to perhaps the most famous of them all, ORC-4, nicknamed the cloverleaf ORC for its irregular, clover-like shape. This object was first spotted in archival data from India's Deep Sky Radio Array and has, since become the most extensively studied ORC to date. Observed in radio, optical, and X-ray wavelengths, the cloverleaf ORC lies about 600 million light-years from Earth, spanning more than 325,000 light-years across over 3 times the width of the Milky Way. A composite image shows its radio glow in red, optical light in yellow-white, and X-ray emissions in blue. In 2024, a team led by Dr. Helena Corvus at the Mauna Kea Summit Observatory detected intense fluorescent oxygen emissions across 130,000 light-years of the cloverleaf's vast structure. This glowing nebula of heated, compressed, or shocked gas appeared to have been triggered by a fast-moving explosion. Dr. Corvus suggested it may have resulted from a starburst termination shock, echoing one of the earlier hypotheses for ORC-1. Her team calculated that the stars within the central elliptical galaxy are around 6 billion years old. Their simulation showed how a violent burst of star formation, followed by overlapping supernova explosions, could drive massive outflows that create both a radio emission sphere and a gas bubble like the one observed. But this isn't the only explanation. That same year, another group led by astrophysicists Dr. Elias Brandt and Dr. Leon Zhou at the European Horizon X-ray Observatory detected diffuse X-rays for the first time in an ORC. Their data suggested that the cloverleaf might have formed through a galaxy group merger. In this scenario, 2 clusters of galaxies collided, sending shockwaves rippling through the intergalactic medium, leaving behind a colossal bubble of radio light. The problem is that not all galaxy mergers produce such enormous circles, so why this one? And even more puzzling, does the cloverleaf truly qualify as an ORC at all? Its diffuse cloud-like shape lacks the clear, bright edges seen in others. What's clear is that the cloverleaf ORC, like all the others, refuses to give up its secrets easily. With every new discovery, the mystery deepens. Dr. Marcus Rowan points out that not every cloverleaf-shaped radio cloud belongs to the ORC family. Similar structures have been seen in other galaxy groups, but many of them don't meet the criteria to be classified as true ORCs. The only way to tell them apart is with more detailed data. Deeper radio and X-ray surveys will be essential to uncovering hidden structures and deciding which ones are genuine ORCs and which are near misses. Fortunately, astronomers already have a growing list of candidate ORCs objects that might expand our catalog and provide valuable comparisons to those already confirmed. What once carried only the cryptic WTF label now has a proper name: odd radio circles. But even with a name, the mystery of their origins continues to puzzle astronomers. In the meantime, powerful projects like the Celestial Evolution Survey (SEAS) and the Southern Sky Array Pathfinder (SSAP) keep adding fresh discoveries. While examining CES data for the small Starstream galaxy, a nearby dwarf system, researchers stumbled upon the ghostly remains of 2 previously unknown supernova remnants. Not long after, in 2023, another remnant was uncovered, this one only about 4,200 light-years away, making it one of the closest supernova leftovers ever identified. Roughly 130 light-years across and just 13,000 years old, it's practically a newborn on the cosmic scale. These breakthroughs highlight how surveys designed to map ORCs often uncover unexpected treasures. Beyond supernova remnants, the CES project is also pushing forward with machine learning and citizen science. Through the initiative known as Radio Galaxy Quest, CES ORGQCES. Over 2,000 volunteers have already helped classify more than 92,000 sources out of an eventual target of 4 million. Among those may be more ORCs hiding in plain sight. The best part? Anyone can participate. Just visit zooniverse.org and search for the Radio Galaxy Quest CES project to start contributing to real astrophysical research. As instruments continue to evolve, astronomers are certain they'll discover many more ORCs and probably objects we can't yet imagine. Each new find not only brings us closer to understanding these radio rings, but also teaches us about the life cycles of galaxies, the power of starburst events, and how gases can travel across intergalactic space long after their galaxies of origin have changed or died. For now, though, the mystery remains unsolved. The leading hypotheses, from black hole mergers to starburst outflows to galactic jets, are tantalizing, but none yet hold the definitive answer. Unlocking the truth will require cosmic archaeology on a scale almost beyond comprehension, sifting through mountains of data, spotting faint patterns, and rigorously testing every idea. It might sound overwhelming, but with the right tools, learning how to think critically about problems like this is something anyone can do. And that's exactly where today's sponsor comes in. Bright Mind Academy is an interactive learning platform designed to sharpen your skills in science, data, math, and technology. Their courses cover everything from logic and reasoning to artificial intelligence, with lessons built to be hands-on and engaging. Instead of passively watching, you're actively solving problems and strengthening your understanding. And because the lessons are bite-sized, it's easy to fit them into spare moments, whether you're waiting for a ride, taking a break, or relaxing at home. If you want to train your brain to think more like a scientist or explore a brand new field, this is a great place to start.